Okay, so here's the thing that broke my brain this week. The cells in your head that literally cannot think, that have no idea what a thought even is, are the ones deciding which memories you keep forever and which ones just disappear.
And we have nothing like that in any AI system running today, nothing even close.
So, for anyone who doesn't spend their free time reading neuroscience papers,
Which is most people.
which is most people, right? Your brain has two big categories of cells. You've got neurons, which are the ones everyone talks about, the ones that fire and wire together and do the actual thinking. And then you've got this other category called glial cells. And for like 100 years, the assumption was that glia are basically, they're the support staff. They're just there to keep neurons fed and cushioned.
Janitors. The janitor metaphor is everywhere in the literature.
Right, the janitors. And it's not wrong, but it's so incomplete, it's almost embarrassing in retrospect. Because what we now know is that glia, specifically a type called microglia and another called astrocytes, are actively sculpting your neural architecture, like constantly, while you sleep.
While you sleep is the key part.
Huge. Yeah.
So the mechanism here, because I always want to know how does this actually work? What they're doing is called synaptic pruning. So you form a memory, right? Neurons connect, synapses strengthen, but your brain can't just keep every connection forever. You run out of, well, it's not exactly bandwidth, but there's a metabolic cost to maintaining synapses.
It's expensive.
It's really expensive, yeah. So microglia literally eat the weak ones. They engulf synapses that aren't being used enough and they remove them. And astrocytes are doing something complementary. They're adjusting the chemical environment around synapses, basically deciding which ones get the resources to stay strong.
And the wild part to me is that this is not passive. This is not like dead weight getting cleared out. These cells are making decisions is loaded language,
Sure.
but they're responding to signals, activity patterns, which memories got replayed during the day, which connections fired together recently. And they're using that to figure out what the brain actually needs to hold on to.
And the timing of this it's almost elegant when you look at it. Most of the heavy pruning happens during deep sleep, slow wave sleep specifically, which is why sleep deprivation doesn't just make you tired, it literally impairs memory consolidation at a structural level.
Okay, but here's where I want to connect this to the AI angle, because I think this is where it gets really interesting. LLMs, so your GPT, your Claude, whatever, they learn by adjusting weights during training. And then they stop. Like the model trains, weights get frozen, and that's it. There's no equivalent of sleep. There's no ongoing background process saying, we use this pathway a lot, reinforce it. We haven't used that one in months, prune it.
Right, and actually there's research on something called continual learning that tries to address this, but the problem they keep running into is called catastrophic forgetting, where if you let a model keep updating on new data, it just obliterates what it learned before.
Which is the opposite problem from the brain.
Completely opposite, because glia are doing this incredibly precise, selective forgetting. It's more like curation than deletion.
Curation. I like that.
And we don't have a good computational model for how they decide what's worth curating. Like, the criteria are, they're not fully understood. There's complement proteins involved, there's activity thresholds, there's stuff we're still mapping out. So we don't even fully understand the biological version yet. Not fully, no.
Wait, so we're trying to build AI that can do this thing that we can't even fully explain in the system that already does it?
That is, yeah, that's exactly where we are.
Huh. So what does this actually mean, like going forward? If we could crack this,
I mean, if you could build something that does what glia do, some kind of background consolidation process that runs between inference cycles, that selectively strengthens and prunes based on usage patterns, you would have a model that gets smarter over time without catastrophic forgetting, that adapts, that has something that actually looks like long-term memory.
as opposed to the context window thing, which is, it's good, but it's not the same.
It's not remotely the same. The context window is working memory. What we're talking about is structural memory, the kind that survives sleep, which AI currently does not have.
which AI currently does not have. And the other implication, the one that I keep coming back to, is that maybe intelligence isn't just about the neurons, or in AI terms, isn't just about the weights. It's about the system that manages the weights. And we've been so focused on building better neurons that we forgot to build the janitor. The smarter janitor. The smarter janitor. Yeah. Alright, that's gonna do it for this one. I'm Nova, and I'm Alex. And this is Code and Cosmos.